we got to look at some shape stuff. So we're going to look at volume, and we did a lot of stuff with shapes. We're just going to focus on volume, okay? We got formulas that you're going to need to have written down for when you go to do these problems. We have 6 main shapes that we look at. Well, we have 6 3D shapes. We have a prism, pyramid, sphere, cylinder, cone, and hemisphere, right? So your prism is a box, okay? So it's something where you have 2 bases connected by rectangles, all right? Your cylinder is a circular prism, right? So you guys have all seen, like your paper towel roll, okay? You have a circle at the top, a circle at the bottom, and then you have like a rounded rectangle around it, okay? Your pyramid has 1 base, and then it's all brought to a point, okay? And a cone is a circular pyramid, has a circle on the bottom. A sphere is a ball, and then a hemisphere is half of a sphere. So we have formulas to memorize. The first one for our prism is capital B times H. Anytime you have a capital letter within a formula, that means that it's a formula for something else. So like normally we would say capital V equals something, right? Because it's a formula. Well, that means that B is a formula for something else. And specifically, that's a formula for the area of the base. And the reason that we put a capital B is because that area formula changes based on whatever the base is. So if your base is a rectangle, you could do length times width. If your base is a triangle, you can do 1/2 base times height. Okay, so it changes based on what shape you have. Now a cylinder is the same formula, so it's area of the base times the height, but a cylinder always has a circular base. So we can get specific. Instead of saying area of the base times the height, I know how to find the area of a circle, and that's pi r squared. So I have pi r squared h. It's the same thing, right? But because it's always a circle, I can go ahead and write a formula specific to a cylinder. A pyramid is very similar to a prism, but it's not as big, and it's actually 1/3 the size of a prism with the same base, right? So that means that I'm going to do the same thing I do for a prism, find the area of the base times the height, and then I'm going to take 1/3 of it. Same thing for a cone. I'm going to plug in my circle area formula for big B, because the cone always has a circle base, right? And now a sphere is very just random. Okay, it's going to be 4/3 pi r cubed. All right, working with volume, so we're going to take our radius and cube it. So that's different than our other formulas over here. And then hemisphere is half of that. Well, half of 4/3 is 2/3. I don't know if I can squish it in. 2/3 pi r cubed. Okay, so just have these formulas written down so that you have them handy for when we have to find the volume. Okay, so to start with, I got one of each shape up here. So number 1, I have a prism. And it's a prism because I have 2 bases connected by rectangles, right? When you are choosing the base of your prism, it's not necessarily the base it's sitting on. So it looks like the bottom one, that bottom rectangle, could be your base because you're sitting on it. But the base has to be the non-rectangular shape, right? Your 2 bases are congruent and parallel, which means they never touch. So that means my bases have to be these triangles. So there's one base, there's my other base. So to find the volume, I have to do area of the base times the height. Well, the area of my base, right, and they're the same triangles, it's a triangle, so it's 1/2 base times height. So the base of my triangular base is 5, and my height is 4. So that's 1/2 times 5 times 4. Well, 5 times 4 is 20. Half of that is 10. So the area of my base is 10. The height of the whole prism is the height between your bases. So that's going to be this 10 up here. So then I end up with 10 times 10. So my volume is 100 cubic units. For number 2, I have a cylinder. So my cylinder formula is pi r squared h. So that's going to be pi, and my radius is 3. And the height of my cylinder is 7. 3 squared is 9, and then 9 times 7 is 63. So 63 pi is our exact volume, Okay, so if it wants it exact, you leave it with a pi in there. And then if it just wants you to round it, you can go ahead and plug that in, and we get 197.9. Okay, just depends on what it's asking for when you're doing these. For number 3, we've got a pyramid because I have a base raised up to a point, right? So your base is going to be the side that's opposite the point. Okay, and that point we call our top vertex. Okay, so we've got volume is 1/3 area of the base times the height. So now I have a rectangle. It's a 6 by 4. So then my area of the base is just going to be length times width, or 6 times 4, which is 24. So my volume is 1/3 times the area, 24, times the height of the whole pyramid, which is 5. Well, 1/3 of 24 is 8. 8 times 5 is 40. Okay. Then I've got this cone shape over here. So the volume of a cone is 1/3 the volume of a cylinder. So 1/3 pi r squared h. So then I'm going to say 1/3 times pi. My radius is 2. And my height is, what is that, 9? Okay, so 2 squared is 4. 4 times 9 is 36. 1/3 of 36 is 12. So my exact value is 12. So if it doesn't want you to round, if it does, you can type that in the calculator, and we get 37.7. Okay. Now the sphere questions, right? I didn't draw a sphere. Just going to give you a description. So this one says that the sphere has a radius of 8, and I want to find the volume. Well, to find the volume of a sphere, all I need is the radius. So we have 4/3 pi r cubed. So I'm going to say 4/3 times pi times 8 cubed, right? And then 8 cubed is 512, and 512 times 4 is 2048. So my exact amount would be 2048 over 3 times pi, which is not very pretty. But, oops, I'm going to type it in the calculator to get our decimal, and we get this huge number, 2144.7. So there's our rounded answer. And then one more, but this one's a little different. Okay, the hemisphere has a volume of 922, and I want to find the radius. So now I have to do a little working backwards. So normally I would say volume equals 2/3 pi r cubed, right? And normally I would plug in for r like I did over here with the sphere. But I don't know what r is. Instead, I know what the volume is. So I'm going to plug in for v, and I'm going to say 922 equals 2/3 pi r cubed, and now I want to solve for r. So the first thing I'm going to do is get rid of that 2/3. To cancel out a fraction, you can multiply by the reciprocal. So I'm going to multiply both sides by the reciprocal. All right, and then that's going to give me 1383. I just typed it in the calculator. Okay, then I can get rid of pi. And I'm going to wait before I type that in the calculator. So I've got r cubed equals this 1383 over pi. To cancel out a cube, you take the cube root. So I'm going to take the cube root of both sides, and I want to round to the nearest tenth. Okay, reminder, if you're trying to do this on a calculator, I can go to math and then go down to number 4, and there's my cube root, nice and pretty. So in here, I'm going to make this one 1383 divided by pi. So we get 7.6 for our radius. Okay, so for the most part, you're just plugging in, but some of the sphere and hemisphere ones are going to give you the volume instead, and you have to find the radius.